Hey guys, it's Mr. Wolf here. I'm not going to be in class today, so I'm making this video to really give you guys the necessary tools to help you complete your entire hang time lab today. So when we're talking about hang time, we're talking about an object that's being tossed up in the air and comes straight back down. So if we were going to make a distance versus time graph of this, our object is going to start out going at a pretty high initial velocity. Then gravity is going to be pushing it down, so our slope is going to be decreasing until it actually gets to this point about right here where it is at 0 meters per second. It's at rest for a split second. And then gravity is always going to be pushing it back down, and so our slope is going to be increasing. Our speed is going to be increasing there as well. Also, I apologize about some of these drawings. I don't have my stylus today, so I'm just kind of using my finger with the iPads. So sorry if it's a little bit messy. So, how are we going to make this on a velocity versus time graph? Well, look at our slope right here. It's pretty steep. So we start off with an initial velocity, maybe somewhere around there. And our slope is always decreasing for this first part. So we're going to just draw our slope going like that. All right. And remember I said right here it's going to be at 0 meters per second, so that makes sense. On our velocity time graph, we're at 0 meters per second. All right, so what happens next? Well, it's plummeting back to the earth. We're increasing speed, so we could go about this two ways, and I'll accept both in class. The technically correct way is to just keep on drawing your object going down like this. The reason being is that it's now going in a different direction. However, I'll also accept it going like this. The idea, though, is that this object is increasing speed as it comes back to Earth. All right, so how are we going to go about calculating hang time here? Well, remember I said that at this point right here, our velocity is going to be 0 meters per second. We've seen this scenario before with the beginning of target 5, with free fall. And so we're able to calculate that time, at least for right here. We've been able to do this. So here's the nice thing, is that the time that it takes for that object to travel down is exactly equal to the time that it takes to travel up. All right. So if we're able to find this time right here, and this is what we've been finding before, and we just multiply it by 2, we're going to be able to find our hang time. All right, so let's give it some practice. If you guys flip to page 22 of your packet, this is going to be hang time practice number 1. You guys could also fill this out as you go to help you reference for your hang time lab. All right. This guy has a vertical leap of 0.8 meters. All right. So we have our change in distance. It's 0.8 meters. We have our initial velocity. Remember, right at that peak for that split second, it's going to be 0 meters per second. We have our acceleration due to gravity. And we are looking for that time, at least just the time it's going to be taking to go from its peak back to the ground. Right? And we're going to use the equation delta t is equal to 1 initial velocity times time plus 1/2 at squared. Our initial velocity is 0, so this really doesn't matter right now. So when we plug in our numbers, we're going to get 0.8 meters. It's going to be equal to 1/2 9.8 then times squared. So we're going to, if we were to do the math on this, we're going to end up our time being equal to 0.4 seconds. All right. So is this the hang time? No. Remember, all we did right now is just calculate the time it takes to drop. But if we go back to this graph right here, the time that it takes to drop is exactly equal to the time it takes to go up. So all we have to do is multiply this number times 2, and we'll get our hang time. So our hang time is going to be equal to 0.8 seconds. All right, so what about part B? What about finding that initial jump speed? How do we go about doing that? Well, let's look back at the graph. And so if I were to take a line and draw it horizontally through, the slope at this point is going to be exactly equal to the slope at this point. Same thing if I were to draw a line here, the slope is going to be the same here as there. Remember that slope is velocity, so if I drew a horizontal line right here, my velocity, when it fell to the ground, is going to be exactly equal to the velocity that that object was launched at. And the nice thing is with our free fall equations, we can determine how fast that object was going when it hit the ground. So if we know how fast it was going when it hit the ground, that was also how fast it was going when it was launched up into the air. Okay, so now we have this information in mind. Let's work on solving this. So the question is asking, what's his initial jump speed? What was the speed when he launched off the ground when jumping, or what you'll calculate when you were jumping off the ground. So we have our initial velocity, because remember right now we're just calculating that free fall when that object was started right here. We have our time now, that's the hang time, but remember the hang time's 0.8. We're just doing this second half right here, so our time is going to be 0.4 seconds. We have our acceleration due to gravity, 9.8 meters per second squared. All right. And we are going to be looking for that final velocity, right, at which it hits the ground in this case. So we're going to use that equation. Our final velocity is equal to our initial velocity plus AT. And we're going to get, this is going to be 0 plus 9.8 times our time. And our velocity is going to be equal to 3.92 meters per second. All right, so at this point, all we've done is we've just calculated the velocity at which this object, when it was at the top of its peak, hit the ground right here. But we also know that that velocity right here is also equal to the velocity at which it was launched up in the ground. So we calculated our velocity here, but we also know that this is also the exact same velocity at which that object was launched into the air. So this was his initial jump speed as well.